Yes, good morning students. Now today we will discuss about the preparation of colloids. So far we have discussed what are colloids, the type of colloids, classification of colloids. Now we will discuss how to prepare colloid. Colloid को कैसे prepare किया जाता है, right? And the first method is the Bradig's arc method or also called as electrical disintegration method. ये पहला method है. In this, you can see this is the apparatus that we take in a Bradig's arc method to prepare a colloidal solution. So in this what we take is, we take a beaker containing the dispersion medium and that beaker is placed in a ice bath. ठीक है, तो बाहर आइस कंटेनर है, उसके अंदर एक बीकर है जिसमें हमने डिस्पर्जन मीडियम को रखा है एंड इनसाइड दैट वी हैव प्लेस्ड टू मेटल रॉड्स व्हिच आर कनेक्टेड टू द बैटरी. ठीक है, पोटेंशियल डिफरेंस रहेगा. अचानक से हम इलेक्ट्रिकल डिस्चार्ज करेंगे, सो व्हाट विल हैपन, द मेटल रॉड्स will produce an electric arc inside it, a spark would be produced, heat would be released, as a result metal would vaporize. But due to the extreme cooling condition outside, the vapors are not going outside the container, they condense in the solid state, but the particle size of those metallic vapors are very small and they then come into the dispersion medium and you get a colloidal solution. So metal rods में अचानक से जब हम पोटेंशियल डिफरेंस इलेक्ट्रिकल डिस्चार्ज करते हैं, देन द मेटल वेपराइजेस, मेटल के वेपर्स राइज करते हैं, बट ड्यू टू द कूलिंग कंडीशन ऑफ द आइस बाथ द मेटल वेपर्स कंडेंसेस एंड इट condenses into the dispersion medium and they act as dispersed phase then, and then you get a colloidal solution. It's an electric arc method because when suddenly the potential is applied, it produces an arc which generates a spark basically and the metal starts to vaporize, heat हो जाता है तो vapors में convert हो जाते हैं and then due to the cooling condition they convert themselves into the solid form in the dispersed phase in the dispersion medium and we get the colloidal solution. So in this we are taking the metals like gold, the metal rods can be gold, platinum, silver, etc. And when electric arc is struck between the metallic rod, arc is being developed, metal starts to vaporize due to the heat and then they are condensed immediately due to the ice cold condition, resulting in the formation of the particle of the colloidal size, and this is called as Bradig's arc method. This is the first method to prepare a colloid. The second method to prepare colloid is a peptization. Peptization is a process by which we are making colloid, and the process over here is we make a freshly prepared PPT. The freshly prepared precipitate is converted into colloid. ठीक है, प्रेसिपिटेट मतलब वो पार्टिकल नेक्ड ऐसा में दिखते हैं, उसी को एक कोलॉइड में कन्वर्ट कर देंगे, ब्रेक डाउन कर देंगे बाय एडिंग एन इलेक्ट्रोलाइट and the substance adding an electrolyte is called as peptizing agent. So first we will prepare a freshly prepared precipitate and to that freshly prepared precipitate we will add an electrolyte called as peptizing agent which will break down the precipitate into small size chemical. The particle is same, chemical formula is same, but the size will change into the colloidal range, and this breakdown of precipitate to colloid by the peptizing agent is called as peptization. So here a freshly prepared precipitate is converted into colloid by shaking the dispersion medium in presence of small amount of electrolyte. For example, if you have a reddish brown precipitate of ferric hydroxide, you had a precipitate. This was ferric hydroxide precipitate. We add small amount of ferric chloride which is here acting as peptizing agent, and this ferric hydroxide will turn into colloidal size ferric hydroxide, and this conversion of a precipitate into colloid is called as peptization. So here the reddish brown PPT changes into small colloidal particle, and the reddish brown colored solution obtained by adding small amount of ferric chloride to freshly prepared ferric hydroxide is called as peptization. This is one of the example. Or a precipitate of silver iodide. You have a precipitate of silver iodide. You can break down into colloidal particle by adding dilute HCl to it. So here dilute HCl acts as a peptizing agent and you will get silver iodide in the colloidal range. So again this is an example. So you are converting a precipitate which is freshly prepared by adding a chemical called peptizing agent into colloid, and this method is called as peptization. Now what is the cause of peptization? So what is the cause of peptization? Now we have seen we first make a freshly prepared precipitate and to this we add a peptizing agent. Now what happens is, how is the PPT changing to colloidal solution? You had a precipitate. So these are big molecules of the precipitate, freshly obtained ferric hydroxide, and to this when you add the peptizing agent, it has a common ion in it. So this common ion will get adsorbed. There is adsorption of the common ion on the surface of the precipitate. After adsorption, there will be repulsion between these positive charges. As a result, the ferric hydroxide big molecule will break down into small particles of ferric hydroxide in the colloidal range. So it's because of the preferential adsorption of the ferric ion on its surface of the freshly prepared precipitate, the repulsion will break the molecule into colloidal particles. This is the cause that adsorption is happening, which results in repulsion, and hence the breakdown of precipitate into small size colloidal particles. So this is what happens exactly in peptization. How is the PPT changing into colloidal particle? By adding electrolyte. So the basic reason is because of adsorption. Now the next method by which we can make a colloid is by chemical method. So few chemical reaction we can do and we can make colloids. Few example is, the first reaction that you see is arsenic oxide. When you react with hydrogen sulfide, there is a double displacement reaction, basically double decomposition reaction taking place, oxygen and sulfur interchange, and you get arsenic sulfide and water, and arsenic sulfide is a colloidal solution. So you get a colloidal sol of arsenic sulfide, and this reaction is basically double decomposition reaction. So first method, chemical method may be, one of the reaction is chemical reaction, that is double decomposition, by which arsenic oxide changes to arsenic sulfide, which is a colloid. Next method is by reduction. Reduction, you can see AuCl3 when you react with SnCl2, you get Au and SnCl4. So Au chloride, gold chloride forms gold sol, and the reduction of gold is taking place. So the chemical method, the second chemical method may be reduction. So in chemical method, there are different chemical reaction you can use, either double decomposition, reduction. The next reaction is oxidation. Hydrogen sulfide, when you react with bromine, you get hydrogen bromide and sulfur sol. The sulfur particles are in the colloidal range, and this is the oxidation of H2S. So it's a removal of hydrogen, so oxidation reaction also help in chemical preparation of colloids. And the next reaction is by boiling, that is hydrolysis. When you are reacting ferric chloride with boiling water, you get ferric hydroxide, which is a colloid, along with HCl. So ferric hydroxide sol you get. So these are the different chemical reactions by which we can prepare colloid. By double decomposition, reduction. So these are the different methods by which we can make a colloid. Physical as well as chemical methods are incorporated to prepare colloid. Now we have seen the preparation of colloids. Now we shall see how to purify colloids. Colloid बनते हैं अलग अलग मेथड से, but सारे colloid pure हो that is not necessary. So what is purification of colloids? So first we shall know what do you mean by purification. Purification means the process by which the process of removing impurities. The process of removing impurities from a colloid is called as purification of colloid. तो हम क्या कर रहे हैं, colloid में से impurities हटाते हैं और उस प्रोसेस को कहते हैं purification of colloids. Unnecessary chemicals होते हैं, अलग अलग मेथड से बनाते हैं, तो हो सकता है कोई और केमिकल प्रेजेंट हो. So to remove those other chemicals, these chemicals act as impurities, and so the removal of impurities from the colloidal solution is called purification of colloid. Now the first important method by which we can purify a colloid is called as dialysis. So dialysis is a process of separating particles. It's a process of separating the particles of colloids from crystalloids through the diffusion of mixture through a parchment membrane or animal membrane is known as dialysis. So you are having an animal membrane and you are removing the crystalloids from colloid by diffusion of the mixture, and this is called as dialysis. And dialysis is practically also employed to purify a blood. Blood is also a colloid. To purify blood in our body, we normally do dialysis. The same principle applies. Impurities which are present are being removed through a semi-permeable membrane. But electrodialysis chalta hai. We give electric potential, so the dialysis process speeds up. Normally this process without potential difference is a slow process. So to increase the speed of the process, we apply electric potential, and that's called electrodialysis. Principle is same. The basic rule is same. Only thing is we are giving electric potential so that the process increases the speed of the process of purification increases, and that's called electrodialysis. So separating of particles of colloid from crystalloids. तो crystalloid और colloid को अलग कर रहे हैं by diffusion of the mixture through the parchment membrane or animal membrane is dialysis. Now particles of the crystalloid pass through the animal membrane. एनिमल मेम्ब्रेन से क्रिस्टलॉइड पास हो जाते हैं क्योंकि इनका साइज छोटा होता है कंपैरिजन में कोलॉइड से, और उसके ऊपर है और बाहर रुक क्या जाते हैं कोलॉइड के पार्टिकल, एंड कोलॉइडल पार्टिकल आर प्योर. सो नाउ वी शैल सी द एक्सप्लेनेशन इन अ डायग्रामेटिक फॉर्म. नाउ इन डायलिसिस व्हाट हैपेंस इज यू आर हैविंग अ कंटेनर, ठीक है, एंड इन दिस कंटेनर वी आर एडिंग वाटर, फाइन. And then we place a bag, that is a cellophane bag, which contains the mixture which we need to purify. Colloid plus crystalloids are present, and we are adding the impure soul, that is crystalloid and colloid, with the help of the funnel into this parchment membrane. इस बैग में जो cellophane बैग है, इसके अंदर हम impure colloidal solution को ऐड करते हैं फनल की मदद से ऊपर से, और इसको अंदर रख रखा है पानी के सोल्यूशन में, पानी के कंटेनर में. And then the two rods are placed to give the potential difference. Water is continuously being added. So when potential difference is applied, the black dots, that is crystalloid, will come out of the cellophane bag because the particle size is small. And inside the parchment membrane, only the colloid particle remains. So when you apply potential difference, the colloidal particle remain inside, but the crystalloids travels from the cellophane bag into the container, and now the container contains water along with crystalloids, which you can remove from this side opening. Water is continuously being added and impure water is being constantly removed when the potential difference is being applied, crystallite traveled out from the parchment membrane, leaving behind the colloidal particle, as the size of the colloidal particle is big, and this process of removing the impurities from a colloid is called as dialysis. And dialysis, you are giving more potential by the application of electric potential difference, and the process now is called as electrodialysis. अगर ये potential difference apply करते हैं तो वो simple dialysis नहीं, वो electrodialysis है. अगर हम ज़्यादा potential apply करते हैं तो it's called electrodialysis. The purification process increases the speed, and if you don't use the potential difference, it's general dialysis. So this is one of the method to purify the colloidal solution, that is by dialysis. The second method by which we can separate or do the purification of colloid is by ultrafiltration. Ultrafiltration means you are going to use a filter paper which is highly specifically made, which is having very small pores. It's highly specific. It's particularly designed to purify the colloidal solution. Now in this we take normally a cellulose acetate which is coated with a colloidal sole. ठीक है, तो ये क्या करेगा, उस पेपर पे एक स्पेशली डिजाइन फिल्टर पेपर लेते हैं जो अल्ट्रा फिल्टर की तरह एक्ट करता है और कोलोइड में से इम्प्योरिटीज को फिल्टर या रिमूव करने में हेल्प करता है. सो हियर वी टेक अल्ट्रा फिल्टर पेपर, स्पेशली डिजाइन फिल्टर पेपर made by using a normal filter paper. Normal filter paper we coat it with colloidine or gelatin. ठीक है, colloidine solution अप्लाई करेंगे या फिर gelatin डालेंगे और उसके pore size को block करेंगे, and then we will harden the filter paper by dipping it in formaldehyde, and then the filter paper that you get is called ultra filter paper, which is used to separate or remove the impurities from the colloidal solution. And this collodion is basically 4% nitrocellulose solution of alcohol and ether, और ये सोल्यूशन तैयार हम करते हैं 4% नाइट्रोसेल्यूलोज और फिल्टर पेपर पे अप्लाई करते हैं. फिल्टर पेपर को इसमें डिप करके रखेंगे तो इसके पोर्स ब्लॉक हो जाते हैं. सो यू टेक दिस फिल्टर पेपर पे जब आप इम्प्योर कोलोइडल सोल्यूशन को ट्रांसफर करेंगे तो इलेक्ट्रोलाइट्स तो नीचे आ जाएंगे, लेकिन कोलोइडल पार्टिकल इनका साइज बड़ा होता है इलेक्ट्रोलाइट नॉर्मल से, वो ऊपर की तरफ रह जाते हैं, एंड यू गेट प्योर कोलोइडल सोल. सो दिस इज द मेथड. ओनली हियर इज नॉर्मल फिल्टर पेपर यू आर taking a specially designed filter paper called ultra filter paper. So this is one of the method to purify the colloidal solution.